welcome back. And today we shall see one method of system development, and that is traditional waterfall. I'm sure you must have learned about the different phases of the system development life cycles, right? Let me just remind you that there are 5 phases in system development life cycle, and those are planning, analysis, design, implementation, and maintenance. Today we shall see one of the model of system development life cycle, and that is the traditional waterfall model. The waterfall model was the first process model to be introduced. It is also referred to as the linear sequential life cycle model. It is very simple to understand and use, right? In a waterfall model, each phase must be completed before the next phase can begin, and there is no overlapping in the phases. Alright, that means one phase will follow another phase. Alright, there will be no intersection or overlapping among the phases. The waterfall model is the earliest SDLC approach that was used for software development. Each phase is designed for performing specific activity during the SDLC phase. It was introduced in 1970 by Winston Royce. Right? The waterfall model illustrates the software development process in a linear sequential flow. We shall see the following slide. It will show how the traditional waterfall model is designed. Alright. This means that one phase in the development process begins only if the previous phase is complete. In this waterfall model, the phases does not overlap, right? In the waterfall approach, the whole process of software development is divided into separate phases. In this waterfall model, typically the outcome of one phase acts as the input for the next phase sequentially. Alright, that means the output from one phase will act as the input of the following phase. Alright, for example, the output from the planning phase will act as the input for the analysis phase, and so on. The following illustration is a representation of the different phases of the waterfall model. Let us see the illustration. See here, planning, and then followed by analysis, then followed by logical design and physical design, implementation, and maintenance. Alright, each phase will, for example, when the planning phase is completed, then the analysis phase will begin. And also when the analysis phase has completed, then the logical design phase will begin, and so on. Alright, that means there will be no overlapping of phases. Alright, that is why it is also known as the linear sequential life cycle model. Right? The sequential phases in waterfall model are: the first phase in SDLC is planning. See, the first one is planning. In this phase, someone identifies the need for a new or enhanced system. That is, you identify the problem or identify the changes that needs to be implemented in a system or to enhance a system. The second phase in the SDLC is analysis. During this phase, the analyst thoroughly studies the organization's current procedures and the information systems used to perform organizational tasks. For example, requirements determination and requirements structuring. Alright. In the analysis phase, the analyst thoroughly studies the organization's current procedures. That means the analyst will collect the data, he will study the data, and he also study the information system used to perform the organizational tasks. Okay. In the third phase of the SDLC is the design. During design, the analysts convert the description of their recommended alternative solution into logical and then physical system specifications. Let us see the following. The part of the design process that is independent of any specific hardware or software platform is known as the logical design. All right, you will not need any hardware or software in the logical design phase. Okay, you will only need the idea of a system, the idea of a physical system, or the idea of a physical system. Yeah. In a traditional structured approach, once the overall high-level design of the system is worked out, the analyst begins turning logical specifications into physical ones. Right? And then before the physical system exists, then the high-level design of the system is when the high-level design of the system is worked out, then these logical design will be turned into physical one. Right, and this process is referred to as the physical design phase. The fourth phase in the SDLC is implementation. In a structured process, the physical system specifications, whether in the form of a detailed model or a detailed written specifications, are turned over to programmers as the first part of the implementation phase. All right, let me remind you again that in the traditional waterfall model, all right, or a traditional waterfall process, one phase will follow the previous phase once it is completed. All right, they will not overlap or intersect each other. So after the design phase here, then the implementation phase comes. All right, when the physical design phase is completed, then the implementation will take place. During implementation, analysts turn system specifications into a working system that is tested and then put to use. Right? Once the physical design phase is completed, then the analyst will turn this physical system specification into a working system. Once it has been finally tested, and then it will be put to use. The fifth and the final phase in the SDLC is maintenance. In the maintenance, programmers make the changes that users ask for and modify the system to reflect evolving business conditions. These changes are necessary to keep the system running and useful. Right? The final phase of SDLC here is the maintenance. When the working system is put to use, then maintenance comes into actions. All right. During the maintenance phase, the programmers will make the changes according to the needs of the users. All right, and then again, planning will take place after maintenance. All right, and modify the system to reflect evolving business conditions. Let us see the application of the waterfall model. Each software development is different and requires a suitable SDLC approach to be followed based on the internal and external factors. All right, these factors could be the views and opinions of the developer, as well as the views and opinions of the ones who use the systems, that is, we call them as the users. Some situations where the use of waterfall model is most appropriate are requirements that are very well documented, clear and fixed. Waterfall model is most appropriately used when the product definition is stable. All right. Technology is understood and is not dynamic. That means it does not undergo changes from time to time. By By not dynamic, we mean a system or a technology that is static, that does not undergo changes from time to time. Alright, there are no ambiguous requirements. Ample resources with required expertise are available to support the product. Alright, you have ample resources. That means the system or the product that does not undergo changes from time to time. Alright, and when the project is short. The advantages of waterfall development are that it allows for departmentalization and control. A schedule can be set with deadlines for each stage of development, and a product can proceed through the development process models phases one by one. Alright, you can have a schedule for each stage of development. That means for each phases of the system development life cycle. You can have a specific schedule or a deadline for planning, a specific schedule or a deadline for analysis, and so on. That means each phases are to follow one another. Alright, that means analysis will follow after planning, design will follow after analysis, implementation will follow after design, and maintenance will have to follow after implementation has taken place. Alright, development moves from concept through design, implementation, testing, installation, troubleshooting, and ends up at operation and maintenance. Each phase of development proceeds in a strict order. And some are the advantages of waterfall model are as follow. It is very simple and easy to understand and use. The another advantage is that it is easy to manage due to the rigidity of the model. Alright, that means it does not undergo, I'll repeat again, the waterfall model need not undergo changes from time to time. That is why it is easy to manage, because of its rigidity. Its ability to maintain its stability. Alright, each phase has specific deliverables and review process. Phases are processed and completed one at a time. Alright, that means there is no overlapping of one phases with another. Okay, works well for smaller projects where requirements are very well understood. Next advantages, it is that it is clear. It has very clear defined stages. It has a well understood milestone. Alright, you'll always have a clear understanding about the goals and achievement of a system. Easy to arrange tasks. Alright, like I've mentioned earlier, is that you can set up a schedule for each and every phase. Alright, next advantage is that the process and the results are well documented. And the disadvantages would be, the disadvantage of waterfall model is that it does not allow much reflection or revision. That means you cannot revise once the system has been developed. Alright, once an application is in the testing stage, it is very difficult to go back and change something. Right, like I've mentioned earlier, if a system or an organization adopts the waterfall model, that means it must not subject to changes. Alright, and changes cannot occur from time to time. That means a system has to remain stable. Alright, it cannot be dynamic, or it cannot undergo changes from time to time. It is very difficult to go back and change something that was not well documented or thought upon in the concept stage. Once planning is done, then even when the next phase happens, you cannot make any changes anymore. right? The major disadvantages of the waterfall model are as follows. No working software is produced until late during the life cycle. High amounts of risk and uncertainty. Not a good model for complex and object-oriented projects. Alright, okay, for big projects, it is not a good model for big projects. Poor model for long and ongoing projects, right? Not suitable for the projects where requirements are at a moderate to high risk of changing. So risk and uncertainty is high with this process model. It is difficult to measure progress within stages. Alright, it cannot accommodate changing requirements. As I've mentioned earlier, it cannot undergo changes. Then adjusting scope during the life cycle can end a project. Once you want to make the changes in the middle of the life cycle, that means it can end a project, right? Because the main objective of a waterfall model is that each phase, that means one phase has to follow the previous phase, right? Now one phase takes place after another. Integration is done as a big bang at the very end, which does not allow identifying any technological or business bottleneck or challenges that arises. All right, and we shall see the next process, that is prototyping, in the following video. All right, prototyping is that one system development process which usually controls the analysis phase. All right, it is highly implemented or used in the analysis phase, as we have seen earlier. All right, in unit 3, if you remember, we have one method of system requirements that is known as the contemporary method, and under that method you will have prototyping. All right, but then we shall see in detail in the next video about prototyping. Thank you.